1-2, order of operations and evaluating expressions. So our objective for this section is to simplify expressions involving exponents and to use the order of operations to evaluate expressions. So what we're going to be doing is learning a little bit about how exponents work, which you should already know a little bit about, and to talk about our order of operations, which hopefully you've heard of before as well, to evaluate expressions. Our essential understanding is that we can use powers, which is another way to say exponents. We can use powers to shorten how you represent repeated multiplication, like 2 times 2 times 2 times 2 times 2 times 2. So instead of that, we're going to use exponent notation to help us shorten that up, because we don't want to have to write 2 times 2 times 2 times 2 times 2 times 2. So we're going to figure out a better way to do that. So what are exponents really? So first, a power has two parts, a base and an exponent. My base is the part there at the bottom, and the exponent is the little guy right up top. Okay? So together, they're called a power. The exponents tell us how many times to use the base as a factor. So we read that expression right there as power 2 to the third, or more commonly, 2 to the third power, or even better, 2 cubed. So cubed is just a shortcut of writing third power, just like we read that term as 5 to the second power, or the shortcut of saying second power is squared. So we can simplify numerical expressions when you replace it with a single numerical value. For example, the simplest form of 2 times 8 is 16, because 2 times 8 is 16. So when we want to simplify an expression, we're just going to work it out. We're going to see what it equals. To simplify a power, we're going to replace it with its simplest name, which means we're just going to work it out. Okay? So what is the simplified form of these two expressions for problem 1, simplifying powers? So we're going to start with 10 to the 7th power, which means 10 times 10 times 10 times 10 times 10 times 10 times 10. That should be 7. When we multiply them all together, which you can do hopefully in your head, if not, you can use a calculator, we just get a 1 in the front with 7 zeros. So 1, 2, 3, 4, 5, 6, 7. And if we split them up, we see that that is 10 million. Okay? So all we're going to have to do is multiply all these numbers together the right amount of times. And we can do this with decimals as well. So this one is going to be 0.2 times 0.2 times 0.2 5 times. And we can do that in our head again, hopefully, or with a calculator to give us point. Now there's 1, 2, 3, 4, 5 numbers behind the decimal point, which means that my decimal is going to have 5 places. And 2 times 2 times, if I multiply all the 2's together, that's 32. So we got 0, 0, 0, 3, 2. 5 spots behind the decimal point and a 32. Okay, let's try some got it problems. Okay, so 3 to the 4th power. Again, we are going to multiply these things 4 times. So that's going to be 3 times 3 times 3 times 3. So we can do this step by step, right? 9 times 3 is 27, times 3 more is 81. Okay. With some of the harder ones, like fractions, if we can remember how fractions work, we have 2/3 times 2/3 times 2/3, which we're going to multiply across the top and multiply across the bottom to give me 8/27. Okay. And for the last one, 0.5, let's look at a calculator. Let's move it out of the way. Okay. And hopefully on your calculator, you kind of can see that we have a button right here that has some sort of exponent there. We have our button right there for squared, okay? But this button right here is going to be our x to the y power. So when we raise 0.5 to the third power, that didn't work, 0.5 to the third power, we get 0.125. Okay? Next. Our next essential understanding, the next thing we're going to need to know, is that when simplifying an expression, we need to perform operations in the correct order. And this is our order of operations. So if we look at this expression right there, 2 plus 3 times 5, we can think about it in two ways. We could do 2 plus 3 is 5, and then take that 5 and multiply with the other 5 and get 25. But, as you can see, that is wrong. Okay, so that's not the way we're going to want to do it. We want to multiply first and take 3 times the 5 to give me a 15, then add the 2 to give me 17. And 25 and 17 are much different answers. So both of these seem like they could be okay, but only the 17 is correct. Right? This is because the second way uses order of operations that mathematicians over the years have agreed to follow. We're always going to use the following order of operations. Okay? 1. Perform any operations inside grouping symbols such as parentheses and brackets. A fraction bar can also act as a grouping symbol. That is very important. 2. Simplify powers. 3. Multiply and divide from left to right. Add and subtract from left to right. Now, you probably have heard of this acronym, PEMDAS, okay? And some nice little phrases to help you remember it. Please excuse my dear Aunt Sally, or whatever other ones you've heard of in the past, okay? So these mean parentheses, exponents, multiplication, division, addition, subtraction. Okay, the same as we see up here in our order of operations. So parentheses definitely come first, then exponents. However, multiplication and division and addition and subtraction go together. Okay, so multiplication is not more important than division, even though it comes first in my acronym. Okay, when we see multiplication and division, we're always going to go from left to right. Same thing with addition and subtraction. We're always going to go from left to right. Okay, and we want to make sure that we don't make multiplication more important than division and addition more important than subtraction. So when we look at this problem right here to find the simplified form of this expression, we are first going to find parentheses, then the exponents, then multiplication and division, and then there is no addition and subtraction. So let's do it. So the 6 minus 4 would be 4. Or the 6 minus 2 would be 4 to the third divided by 2. Okay, well, 4 times 4 is 16 times 4 more gives me 64 divided by 2, which is going to be 32. Okay. If we maybe had removed the parentheses and it looked like this, that's a much different problem. Okay, because now there's no parentheses to do first. The first thing I would do would be an exponent. So that would be 6 minus 8 divided by 2. Then would come addition and subtraction. So this would be 6 minus 4, which would be 2. Okay, so the grouping symbols do make a large difference when we're trying to solve these problems. Okay, how about part B? Notice that the 2 to the 4th power minus 1 is both over 5. That makes a big difference because we're going to have to do everything up top first before we simplify the expression. So 2 to the 4th power becomes 16 minus 1 over 5, okay, which is 15 over 5. and over means division, so this turns into 3. Okay. That's very important because we want to simplify the numerator or the denominator first and then combine the expression. Because if it's 2 terms on the top or 2 terms on the bottom, we're not going to be able to simplify it as we want to. Let's look at some got it problems. Okay, same thing, simplified form is the expression. Okay, so I look at this problem very carefully. I see everything that's going on, and I see we have an exponent. So that turns into 5 times 7 minus 4 squared is 16 divided by 2. Now I do multiplication left to right. So we start with 5 times 7, which is 35. So that's 35 minus 16 divided by 2 is 8, which gives me 27. In part B, division first, right? Remember PEMDAS. Okay, so division before subtraction. Okay, so when we try to figure this out, we have 12 minus 25 divided by 5 is 5, and 12 minus 5 gives me 7. Whoops, 7. Okay. Now C is a little more complicated, okay, because we got 2 things up top and we got 2 things on the bottom. So what I want to do is I want to simplify the top first, then the bottom. So the top becomes 4 plus 3 to the 4th power is 81 over 7 minus 2. So now I do 4 plus 81, which is 85 over 7 minus 2 is 5. And then 85 divided by 5 gives me 17. Okay, so it is very important to simplify the top first, then the bottom, and then we can combine both terms. And you can see with D, how does the fraction bar act as a grouping symbol? Well, because we had to do the top first and then the bottom, if I actually wanted to write this out without a fraction bar, let's get rid of those so we can see it, we would have 4 plus 3 to the 4th power. If I just put the division symbol there, what does that say? Well, it says that we should do the exponent first, then the division. But that's not the way we did this problem. So we would need grouping symbols. So the fraction bar, when we have an expression like this with a fraction bar, it really does tell us that we have to simplify the top first and then the bottom, the denominator, before we can actually divide. Next, when 2 or more variables or a number and variables are written together, treat them as if they were within parentheses. So an expression like 4xy is the same thing as parentheses 4 times x times y. And xy squared is the same thing as parentheses xy squared. So we evaluate an algebraic expression by replacing each variable with a given number and then simplify the expression using, of course, order of operations. So while these expressions in A and B look a little complicated, they're not, because we know what x is equal to and we know what y is equal to. Okay, so problem 3 is evaluating algebraic expressions. So what is the value of the expression for x is equal to 5, y is equal to 2? Just replace them. So instead of x, we write 5. Instead of x, we write 5 squared plus 5 minus 12 divided by, now this is y, so that's 2 squared. Exponents come first. So we got 25 plus 5 minus 12 divided by 4. Then multiplication or division. There is no multiplication, but there is this division. So we do 12 divided by 4, so that turns into 25 plus 5 minus 3. Add them all up, and we get 27. 30 minus 3. Okay, so we just replace x and y with my two variables, or with my two numbers, and solve. So in the second part, part B, now we have same x and y. So x is equal to 5, y is equal to 2. All right, so now we're just going to replace it. We're just going to go 5 times 2 squared divided by 5 times 2. So that turns into 10 squared divided by 10. 10 squared is 100 divided by 10, so we get a 10. Okay? Let's try some got it problems. So now a is equal to 3, b is equal to 4, okay, in both parts. So when we do these problems, we're going to do the same thing. Okay? Turns into 3 times, whoops, 3 times b, which is 4, minus 3 squared, which is 12 minus 9. I did both steps at once. We should, of course, do the 3 squared first, and then the multiplication, and then the subtraction to give me 3. Okay? Again, a is equal to 3, b is equal to 4 in part B. So we have 2 times 4 squared minus 7 times 3. Exponents first, well, parentheses first, but notice how I wrote this multiplication with parentheses instead of with a dot or instead of with the times. Okay, always easier to do it that way, so you don't get confused. So we're going to do 4 squared first, which is going to be 2 times 16 minus 7 times 3. Exponents first. So now we got 2 times 16 gives me 32 minus 21, and subtract to get 11. Okay? Not too bad. Let's try problem 4, which is evaluating a real world expression. So this is a banking problem. What is an expression for the spending money you have left after depositing 2/5 of your wages in savings? Evaluate the expression for weekly wages of 40, 50, 75, and 100. Okay, so we're going to have to figure out what we know, what we need, and then come up with a plan. So what do you know? You know that savings is equal to 2/5 of your wages. Okay, well that's good. So we're going to need some sort of expression that represents this situation. So let's write an algebraic expression and then figure out how we're going to solve this. So let's use, because we're going to talk about wages, let's use my variable as W. So let's say W is equal to wages. All right, so now we're going to make an algebraic expression. So my spending money, all right, is going to equal my wages minus the part that I put into saving. And so my savings is going to be 2/5 times W. So I can take that expression right there and plug it into there. So my algebraic expression is going to look like W minus 2/5 times W. And that's kind of the hardest part of this problem. Okay? Now that we know what the algebraic expression is, let's make a little table. So we have my wages. Okay? We're going to have my formula. And then my saving money. Okay? So in the first one, we want, right, from the question, we want my wages to be 40, then 50, then 75, and then 100. Okay, so all that was in the problem. 40, 50, 75, 100. So my formula is going to be 40 minus 2/5 times 40. Okay, well, if we can remember that this is also a fraction, right? 40 over 1. I'm going to do 2 times 40 divided by 5. Take that answer. Do 40 minus 2 times 40 divided by 5 is going to be 16. So 40 minus 16 gives me 24. And we can do this the same for the rest of these. So that's 50 minus 2/5 times 50, which would give me 30. And you can check this all on your calculator. 75 minus 2/5 times 75. Another way to multiply fractions quickly is to reduce it uh, before you even multiply it. So I can actually take this 5 and cancel with this and give me 15. So now that turns into 75 times 30, 75 minus 30, which is 45. And finally, we have 100 minus 2/5 times 100, which is $60. Okay, let's look at one more like that. Okay. So my got it problem for this section is the shipping cost of an order at an online store is 1/10 the cost of the items you order. What is an expression for the total cost of the given order? So we're going to have 43, 79, 95, and 103. And so this is going to be the same thing. Cost is going to be equal to my cost is going to be, what's the cost of items you order? What is the expression for the total cost? Total cost is going to be the cost minus 1/10 of the cost. Shipping cost. The shipping cost for an order at an online store is 1/10 times the cost of the items. No, actually, that's not right. So, shipping cost. Oh, well, you have to add. So we're going to take 43. We're going to take, sorry about this. We're going to take the total cost is going to be the shipping cost plus the cost of the item. Cost of the item. So a little different than the last problem, which kind of makes sense. So when you buy something, you got to buy the thing and you got to pay to ship it. So that is going to be your total cost. Okay, so now that we have our formula, which was the hardest part of this problem, okay, we can actually solve for all these different things. So we're going to get, so my shipping cost is going to be 1/10 times 43 plus you got to pay for the item. Okay, so that's going to be 43 plus 4.3, which gives me, sorry, 4730. Always with money, we want to put 2 decimal points. Okay, same thing, 1/10 times 79 plus 79. So that's 79 plus 7.9 gives me 86.90. Okay, and then you can leave the other two to figure out on your own there. The correct answers would be 104.50. So for 95, that would be 104.50. And for 103, that would be 113.30. Okay, so you can try those and see if you can get those two. Okay, and that brings us to the end of section 1-2, order of operations and evaluating expressions. By now, you should know how to calculate those three. These types of problems should be no big issue, right? We have X, we have Y, you just plug them both in. For vocabulary, do we understand both of these? Is that the exponent would be the 3 at the top there. And for error analysis, a student simplifies an expression shown below. Find the error and simplify the expression correctly. Where was the error? What did the student do? So if we look at this problem right here, we can see that he subtracted those two to get 15 before multiplying by the 2. You should multiply the 8 and the 2 together. He correctly did the exponent first, but the next step should have been multiplication. Okay. So again, that was 1-2, order of operations and evaluating expressions.